Now we will discuss about the properties of rational numbers. So in this case we will discuss about the properties of addition, subtraction, multiplication and division of rational numbers. So at first we will discuss about the closure property. What is called closure property? If two rational numbers are added or subtracted or multiplied or divided, then we will get a rational number as the result. Clear? So let us verify it. Now if we consider 3 by 4 and 5 by 6 are two rational numbers, so in case of their addition we can write 3 by 4 plus 5 by 6. Now we need to check the LCM of 4 and 6, that means the denominator of both the rational numbers. We know that the LCM of 4 and 6 is 12. Now we need to do something such that both the denominators of the rational numbers becomes equal to the LCM, that is 12. So if we multiply the denominator of the first rational number, that is 4, with 3, then we will have 4 into 3 is 12. So to maintain the equality of the rational number, we need to multiply the numerator of the rational number also with the same number with which we are multiplying the denominator. So in this case, if we are multiplying the 4 with 3, then we should also multiply the numerator, that is 3, with the 3 to maintain the equality. Suppose if we cancel out the 3, both the 3 with each other, then we will have only 3 by 4. So to maintain the equality, we have to multiply both the numerator and the denominator with the same number. Clear? So for the first case we will multiply with 3, but in the second case the denominator is 6. Now if we multiply this with 2, then we will have 12. So we will also multiply the numerator with the same number, that means with 2. Then in the first case we will have 3 into 3, that means 9 by 12, and in the second case 10 by 12. So both the denominator becomes 12. So if we now add these two numbers, then we can write the denominator 12, okay, and the numerators, in case of numerators we will add the two numerators, okay. So 9 plus 10, so 19 by 12 will be the answer. So it is also a rational number. Clear? So it maintains the condition. So we can say that in case of addition of rational numbers, the closure property is maintained. In case of subtraction, if we consider 5 by 6 and 3 by 4 are two rational numbers, and if we subtract 3 by 4 from 5 by 6, then we will have 5 by 6 minus 3 by 4. So in this case also we need to know the LCM of 6 and 4. We know that. So we know that the LCM is 12. So the same thing is applicable here. So 5 into 2 by 6 into 2, that means 10 by 12 minus 9 by 12. So the denominator is 12, and then we need to subtract the numerator of first one, the numerator of second one from the first one. So 10 minus 9 by 12, 1 by 12 is the answer. So 1 by 12 is also a rational number. In case of multiplication, a by b and c by d, if these two are rational numbers, then what is multiplication? That means a by b into c by d. So in this case we need to multiply the numerator of the first one with the numerator of second one, and the denominator of first one with the denominator of second one. So a into c by b into d. So what is multiplication of two rational numbers? So the multiplication of two rational numbers is the product of the numerators divided by product of the denominators. Okay. So if we consider 2 by 5 and 3 by 4 are two rational numbers, then their multiplication, if we do the multiplication of these two, then we know that 2 into 3, so 6 by 5 into 4, that means 20. So 6 by 20, and both the numerator and 20, and both the numerator and denominator have a common divisor, that is 2. So if we divide the 6 and 20 both by 2, then we will have 3 by 10. So 3 by 10 is the answer. So 3 by 10 is also a rational, also a rational number. So we can say that in this case also closure property is maintained. In case of division, if we consider a by b is a rational number and c by d is also a rational number, so in case of division, a by b divided by c by d, right? Now if a by b and c by d are two rational numbers, then a by b divided by c by d is the rational number obtained on multiplying a by b with the reciprocal of c by d, that means d by c. We know that the reciprocal of c by d is d by c, that means c by d, the reciprocal of c by d is 1 by c by d, that means d by c, is not it? The denominator will become numerator and the numerator will become the denominator in case of reciprocal, is not it? So we can write a by b into d by c. So in case of multiplication, we know that there will be the product of the two numerators divided by the product of two denominators. So a into d by b into c will be the answer. So we can say that division is the inverse process of multiplication. Okay. Now if we consider 3 by 4 is a rational number and 5 by 12 is also a rational number, then the division is 3 by 4 divided by 5 by 12. So 3 by 4 in when the sign changes from division to multiplication, then the denominator of the divisor will become numerator and the numerator of the divisor will become the denominator, is not it? That means the reciprocal of this, is not it? So 3 by 4 into 12 by 5. So the result will be 36 by 20. 12 into 3, that means 36, by 5 into 4, that means 20. So 36 and 20 both have a common divisor 2. So if we divide 36 and 20 with 2, then we will have 18 by 10, and 18 and 10, these two also have a common divisor 2. So if we divide 18 and 10 both by 2, then we will have 9 as numerator and 5 as denominator. So 9 by 5 is the answer, and it is also a rational number. So in this case also the closure property is maintained.